Some of them almost certainly have planets, and it's reasonable to imagine that some civilizations could be far more advanced than our own. NASA recently announced the discovery of around 500 new planets, all orbiting distant stars. Our position in the universe is relatively calm. We live around a normal star, with 8 planets rotating around it, one of which supports life. For every single grain of sand on Earth, there are roughly 10,000 stars in the universe, more or less. In actual numbers, this equals somewhere between 10 superscript 2 superscript 2 and 10 superscript 2 stars. Now, if we estimate that about 5% of those stars are similar to our Sun, that leaves us with around 500 billion Sun-like stars. Let's continue. If 1 in every 5 of those stars contains a planet in the Goldilocks zone, the area where liquid water can exist and life could form, that gives us about 100 billion Earth-like planets. Out of those, if even just 1% develop life, then every grain of sand on Earth could represent a planet capable of supporting life. Using this approach, scientists estimate there are roughly 100 billion stars in the Milky Way galaxy alone. This would suggest more than 1 billion Earth-like planets in our galaxy. And if just 1% of those planets form intelligent life, there could be anywhere from 100,000 to 1 million civilizations in the Milky Way. SETI, the search for extraterrestrial intelligence, has been monitoring signals from space for decades. Yet from all this potential, they've received exactly 0 confirmed signals. So the question remains, where is everybody? This mystery is known as the Fermi paradox. If the universe contains so many stars and potentially habitable planets, why has no other advanced life been found? Or why haven't they found us? The reality is that planets are extremely common. Over just the past few years, our understanding of habitable exoplanets, planets outside our solar system that resemble Earth, has increased dramatically. Scientists have confirmed around 3,800 exoplanets so far, and some of them may be capable of supporting life. One example is the TRAPPIST-1 system, which is believed to contain 7 potentially habitable planets orbiting a star about the size of Jupiter. These planets are rocky, may contain water, and share characteristics similar to Earth. With so many Earth-like worlds, why hasn't at least one advanced civilization been detected? Even as we continuously search for life in the universe, it's almost as if we already assume it exists. For instance, when astronauts first returned from the moon, they weren't allowed to walk around or speak to the media right away. Instead, they were placed under strict quarantine for weeks. This was because scientists feared that even simple bacteria or microbes from the moon could pose a serious threat to life on Earth and potentially cause widespread harm. This concern was taken so seriously that the procedure continued throughout several Apollo missions, up until Apollo 15, when it became clear there was no danger. However, this doesn't take into account the fact that humans may have contaminated other celestial bodies as well. There are now thousands of pounds of human-made debris left on the moon. While it may be unlikely, it is still possible that bacteria could survive on some of those objects, meaning we may have accidentally introduced life to another world. This is the same reason satellites are often sent into a planet's atmosphere to burn up when their mission is complete, to prevent spreading Earth-based organisms to environments where they don't belong. As unsettling as this might seem, history shows that almost every prediction we've made about the universe has been proven wrong in one way or another. Approximately 100 billion people have lived throughout human history, and nearly all of them died without knowing what the planets actually were or understanding the true nature of the universe. Around 99% of all species that have ever lived on Earth are now extinct. Could humans be next? Centuries ago, we believed in a geocentric model, thinking everything in the universe revolved around Earth. We even thought the Earth was flat. Today, we know none of that is true. Based on that track record, it seems foolish to assume we are the only life in the universe. Astronomer Frank Drake agreed with this idea. He believed there was no possible way that humanity was the only intelligent life in existence. Are we really alone in the universe? There has to be some way to estimate where everyone else might be, and from that simple idea came what we now call the Drake equation. The Drake equation breaks the search down into all the required steps for a civilization to exist and survive on a galactic scale and possibly be detected. It organizes the process step by step and at the end, we are left with a number that represents how many civilizations could be waiting to be discovered. In short, the Drake equation uses 7 variables that, when multiplied together, help estimate how many civilizations might exist in our galaxy at this very moment. It is a structured way of calculating what we questioned earlier in the video. Each part of the equation has a specific meaning, and while it may seem complex, it can be simplified. N represents the number of civilizations in the Milky Way that we might be able to communicate with. This is the main number we want to determine. Our asterisk is the average rate of star formation in our galaxy. We don't know the exact number of new stars created each year, but we do know the amount of solar mass formed annually, about 3 solar masses. That means roughly 3 average-sized stars form each year. Since our sun is fairly typical, this estimate works as a reliable reference. It could be one massive star or several smaller ones, but this is one of the more certain values in the equation. F is the fraction of those stars that have planets. While this number isn't perfectly known, some estimates suggest it could be between 10% and 50%. Though not exact, scientists believe this value is reasonably high. N is the average number of planets per star that could potentially support life. First, we identify the stars. Then, we look at how many of them have planets. Next, we focus on which of those planets are in the habitable zone. Current research suggests that around 1 in every 5 stars may have a planet in a zone where liquid water could exist, making this value somewhat reliable as well. F is where things become more uncertain. This represents the fraction of habitable planets that actually develop life at some point. Our data on life is extremely limited. In fact, it comes from only one planet, Earth. Out of the countless planets in the universe, we only have one confirmed example of life. It's also possible that extraterrestrial life doesn't function like life on Earth. It may not need water, oxygen, or even sunlight. With trillions of planets under different conditions, there could be many unknown ways for life to exist. This makes F very difficult to calculate. F is the fraction of life-bearing planets that go on to develop intelligent civilizations, similar to ours. Once again, our only reference point is humanity. One question worth thinking about is, if Earth is a fairly average planet in an average galaxy, orbiting an average star, how did intelligent life emerge here? Maybe life itself isn't rare, but intelligent life, capable of questioning its own existence, might be. Among all the species on Earth, humans are the only ones who have developed complex language systems. Alien forms of communication might be completely beyond our understanding. They may not use language at all, or rely on senses that we don't possess. It's similar to humans trying to understand and speak the language of whales. Most of us simply cannot. The same concept could apply when considering how extraterrestrial beings might communicate. On Earth, very few life forms use verbal communication like we do. Even with ancient human languages, we have reference points and shared patterns that allow us to decode them. But with alien civilizations, there is nothing familiar to compare to. While we can study and compare our own languages, applying that process to a completely unknown species or civilization may be far more complex. On the other hand, thinking about the galaxy in our own human terms feels somewhat backwards. In the Drake equation, FC represents the fraction of civilizations that develop detectable technology, and once again, we only have ourselves as an example of this. Imagine if Earth had formed just 1 year ago. In that case, humans would only be about 10 minutes old. The Industrial Revolution would have taken place only 2 seconds ago. For most of our existence, we've had absolutely no ability to even attempt communication with alien life. It is an extremely recent development. We've been sending radio waves into space for roughly the last 100 years, yet humanity has existed for as long as 1 million years. That means for only 0.0001% of our total history have we even had the potential to contact extraterrestrial life. And remember, radio waves are the only method we have tried so far. In another 100 or 200 years, we may discover a new form of communication that is millions of times more effective than radio transmission. That could easily explain why we haven't received any response. Trying to make contact using radio waves might be similar to attempting to communicate across the world using a carrier pigeon when everyone else is using the internet. It would simply be outdated and ineffective. We also assume that other civilizations use technology similar to ours. The problem is either we are the first to achieve this level of advancement, or we are far behind, and others are far more developed than we are. However, if they are capable of detecting radio signals, they may have already discovered our presence. After all, almost all modern systems are now heavily controlled by advanced computing. The final variable in the Drake equation is L, which refers to the lifespan of a technological civilization. It defines how long that civilization remains detectable before it disappears, changes, or destroys itself. Extraterrestrial societies might send out signals for long periods until they evolve beyond those methods, collapse, or possibly transition into a simulated existence. The longer the value of L, the more advanced that civilization is likely to become. This is where the Kardashev scale becomes useful. I've made an entire video on this topic before, but here are the key points. First is a Type 1 civilization, which is able to fully control and utilize the energy of its own planet. We are gradually moving toward that level and are currently estimated to be around 0.72 on that scale. A Type 2 civilization is capable of harnessing the full power of its home star. The farther a planet is from its star, the less energy it receives. Earth collects an extremely tiny fraction of the sun's total output. Although many hypothetical megastructures have been suggested to capture stellar energy, we are still very far from reaching that stage. Next is the Type 3 civilization, a society that is spread across and controls an entire galaxy, having access to countless worlds and immense resources. However, based on current observations, there is no detectable evidence that even one such civilization exists, and that is difficult to explain. The universe is approximately 13.8 billion years old, while Earth has only existed for about a third of that time. This means there were at least 5 billion years before Earth even formed, during which other intelligent civilizations could have developed and possibly disappeared. Yet still, we see no signs of them. If a species could build a massive ship capable of traveling at just 10% of the speed of light, it could cross the entire Milky Way in around 600,000 years. That sounds like a long span, but compared to the galaxy's estimated age of at least 10 billion years, it is almost insignificant. All it would take is one species choosing to expand, and they could spread throughout the galaxy. So if it is even remotely possible, why haven't we seen any evidence of this? The answer may actually be reassuring. It could mean that the great filter lies ahead of us, not behind us. There may be life elsewhere in the universe, but enormous obstacles stand in the way of long-term survival and expansion. The great filter theory helps explain this idea. Imagine there are 1 million civilizations within the Milky Way. Not all of them will survive long enough or evolve far enough to dominate the galaxy. Certain barriers must be overcome along the way. The first major barrier could be the development of multicellular life, and perhaps that stage is more difficult to achieve than we realize. Crossing the next barrier assumes we already have thoughts and self-awareness. The next step is understanding basic technology. That part is manageable. But then the idea of time travel appears, and suddenly progress becomes far more difficult. It feels like we are stuck. There are forces that prevent us from moving forward and becoming a true galactic civilization, but we don't fully understand what those forces are. The Milky Way alone contains hundreds of billions of planets. Yet when we search for other life, we find nothing. Where is everyone? The great filter theory suggests that there are specific stages a species must pass through to dominate its planet, its solar system, its galaxy, and beyond. Some of these stages may be nearly impossible to overcome. The real mystery is whether humanity has already crossed that barrier or whether it still lies ahead. If it is behind us, then we have survived an almost impossible test, perhaps becoming one of the first advanced civilizations in the universe. If it is still in front of us, then we face an enormous challenge. For most of human history, the fate of our planet was shaped by events outside our control, such as massive asteroids that caused extinction. However, in just the past 80 years, we have created technology capable of destroying our entire civilization in an instant. We are also developing artificial general intelligence, followed possibly by superintelligent AI. These could represent some of the greatest barriers we must overcome, and they may be where many civilizations fail. If we ever discover evidence of an advanced civilization that destroyed itself while progressing, it would strongly suggest that the Great Filter lies ahead of us, and that would be unsettling. The Great Filter is not a minor challenge. It does not wipe out 99% and leave a chance to recover. Instead, it wipes out 100% of a species, leaving no opportunity for rebuilding. Throughout history, when humans encountered something more powerful than themselves, fear was the usual response. The same goes for ideas like advanced AI or aliens. In most historical cases, the weaker group was eventually eliminated. We saw this with humans and Neanderthals, and later during the colonization of North America. Perhaps this is simply human nature. Based on past patterns, first contact with aliens may be the most dangerous event our species could ever face. That leads to an important question. If we detect another civilization, should we announce that we heard them? The futurist side might say yes, but a more cautious voice would say no. It is possible that other civilizations are already doing exactly that, listening, observing, and choosing not to respond. Advanced species might be watching us, studying our development as if we were a science experiment on a galactic scale. I mentioned this before in my AI discussion, but it applies here too. When observing something that could become far more powerful than you, caution is necessary. AI could help us explore the galaxy and connect with other life forms, but it could also lead to our extinction. If a superintelligent AI decided that extraterrestrial life was a threat and tried to eliminate it, it would likely fail. That failure could then lead to our own destruction. One of our greatest creations could end up causing our downfall. On Earth, if AI becomes too powerful, we assume we can simply shut it down. But what if other civilizations are doing the same thing with us? They may be observing how intelligent life develops. When we reach a certain level, they could decide that the experiment must end. It sounds unbelievable, but humans do similar things here on Earth. Think about Antarctica, an entire continent left uncolonized because it is not convenient or suitable for life. Alien civilizations might view Earth in the same way. They may have discovered us, realized we are not unique, and moved on. For all we know, Earth may have been visited long ago. There was an enormous stretch of time before humans even existed. During that time, other civilizations could have passed through and found nothing here worth staying for. Modern humans have only existed for about 50 to 100,000 years. Compared to Earth's 4.5 billion year history, that is nothing. Across a galaxy filled with planets, there will be many places that simply are not worth the effort to colonize. Why waste time on a world that offers no benefit? Aliens would not come to Earth without a meaningful reason, whether positive or negative. The Drake equation is only a theory, and many of its values are educated guesses at best. There could be millions of civilizations in our galaxy, or none at all. If just one variable equals 0, then we are completely alone. Both outcomes are mathematically possible. Enrico Fermi asked one of the most important questions of all time. Where is everybody? Yet he was also a key figure in developing nuclear weapons. The same species that dreams of colonizing the galaxy also has the power to destroy itself instantly. Every day, we search for signals from other civilizations. We scan the universe for technosignatures, unnatural patterns like city lights on distant worlds. We analyze the atmospheres of exoplanets, searching for chemical signs of life. In 1974, Frank Drake sent the Arecibo message toward the M13 star cluster, a coded message describing humanity. We launched the Voyager probes carrying information about who we are and where we are from. We are desperately trying to find other life in the universe, while also giving it a detailed map back to us. Our desire to not be alone may be blinding us to the potential risks of being found. So, are we nearing the end, or just beginning our journey as a species? Are we closer to extinction, or to becoming something greater than we can imagine? Earth has limited space, and once that limit is reached, there is only one direction left to go: outward. Time is running out. The clock is counting down, and there is a part of me that fears what will happen when that clock finally hits 0.